So I think we've got power from the battery into a controlled situation. Now we just got to get that power in the water. So what are some good ways that teams can look at getting that motor turning? And
so we didn't really talk a ton about motors just yet. I talked earlier about the sort of, you have to think about the motor controller combo while you're thinking about the battery. I would say probably the three most common ways that I've seen people integrating propulsion into these both manned and unmanned boats would be, one would be an outboard motor that they've converted, where they basically, I guess there's more versions than I'm thinking, but let's just start with some of the basics.
I think that's a good starting spot, though.
So the nice thing about using an outboard motor as the base to convert from is that you take some of the difficulty, some of the complexity out of the overall problem to be solved. Yes, you have less that you completed on your own, perhaps, let's say, but what you don't have to tackle is, how is this contraption that you've created going to hook onto the boat? And then if you want to be able to steer it, is it going to be strong enough to remain intact, but also have the sort of flexibility and agility to do what it needs to do and spin that prop back and forth and do all those things?
Right.
The ability to pull a lever and kick it up as you're coming out of the ramp and not having to like unbolt it and lift it off, perhaps, if it's all truly a custom built type of thing.
Right.
That's so far the two boats that we've raced at PEP have both had that approach, and we've found them to be a good approach.
And we've touched on it occasionally over the course of this, but waterproofing is such a big deal. And if you get something that was already in the water and showed that it can handle the water.
Well, not only that, but the parts that are underwater are not the electrical parts.
Yep.
So if your lower unit is a sort of mass manufactured commercial part of the kit, then as long as it's performing and it hasn't got, doesn't have some significant problem from its previous life as its, gas-powered, version of itself, even if you have an issue where some water leaks or something happens down there, your electrical stuff is all a few feet above that.
Yep.
So that definitely helps. Whereas if you are building some of the outboards, like trolling motors, for example, or some of the more modern versions of the electric motors, outboards, the brushless internally, motors where it's an inline motor in a pod. The approach, the idea of them is awesome. You've got passive cooling because everything's underwater. The metal casing of it dissipates the heat. In theory, that's great. They're quieter. You can have them at whatever height that you want, so that way if you are doing something like a foil or whatever, there's not the shaft that has to come up. There's so many reasons that that's a good approach, but the difficulty is it's got to be absolutely water sealed, because if water gets in, it wreaks havoc, and so a tiny bit of water could make a sort of a frothy mess. Any significant amount of water probably will kill any electronics that are inside.
Yeah.
And so you can try to pot your electronics and do things to seal them. So potting them, sealing them with epoxy or some kind of a silicone sealant or whatever. The more you do that, the more you also contain the heat. So you have to make sure you have ways to get the heat out of those with heat sinks that bridge the gap to your outer casing.
Sure.
Or else you still could have cooling issues like that.
Yeah, I think the one other thing that these teams run into when they get an existing outboard and then put an electric motor on top is that you do need to do a mechanical engineering build of the connector, right? And a lot of times that ends up being like a female-to-female connection.
The electrical connection, you're saying?
No, I'm actually talking about the mechanical connection from the drive shaft that's coming out of your DC motor and then connecting into and that is a non-trivial job. Actually, I was at one senior design review and there was laughter because of how much the drive shaft was shaking.
Yeah.
And you never want to hear laughter during your design review. But I think like what it speaks to is like you've got to clean out get all the gas components out of there as quickly as possible, and really like that is going to need to be tested and tested again about how you're getting those things to sync up after this bottom part has been out in the world for probably 30 years, and this is a new part.
And I could give some approach tips from our experience. The first ones that we built, we basically made the coupler, and it was probably the version that was being laughed at, It was not a well-balanced, very precise fitting. Now, this was, I guess, when we had maybe lower powered motors as well, so it was less explosive in I guess, at higher speeds.
You could deal with a shimmy.
We could deal with a little bit of a shake, yeah. But what we ended up doing was it was very much hand fabricated because thinking of the tooling that we had in our approach, what we were limited to in our approach, it was a handmade coupler from like bits of metal and washers that were all stacked up, and we were trying to build splines and TIG weld it all together and make it fit, and it worked, but it wasn't pretty and it wasn't balanced. And in hindsight, there's way easier ways to go about it. And so in the second one that we converted, which is the same setup that we've currently got on the wooden hauled boat, we've done this going forward with the latest version as well. The easiest way that I found, the easiest way without spending any money is when you're taking the power head off, if it is a non-reversible dismantling and you're willing to not be able to reinstall that power head, you can take the crankshaft out and just cut off the end of the crankshaft where the coupler is already there. You've already got the piece that used to fit right onto there, and then all you have to do is figure out how you're going to take that and make it fit onto your electric motor.
Right.
And so if you could take that piece and put it in a lathe and make it nice and smooth and round, because it's going to probably have the jagged bits coming off from where hooked to your pistons and everything. But yeah, if you could basically smooth that all out, get it all nicely balanced, and then on the lathe, bring it down to a known diameter that you can easily get a coupler to fit on there. Then you can cut a keyway in it. You can easily connect it to a typical off-the-shelf connector of some sort to go between the two. So in the versions, I guess, that we had done before we used those, and I can't think of what they're called, but they're basically couplers that have teeth that come together with a rubber sort of material in between to sort of pad where the not teeth, but the halves come together and mesh together. The beauty of something like that is they have an allowable amount of misalignment, and they still will operate well.
Right.
So if you've got a lot of tooling and ability to make really precise adapters and things, if you're going to be milling it out of a solid chunk of some aluminum, whatever it might be, and everything is square and plumb and perfectly spaced, then you may not have that situation. But we went to the scrapyard and we got a bunch of old steel and we measured it up and cut it out on a bandsaw and welded it together. And then we did put it on a milling machine and flattened out some of the different faces when we got done with that to try to make it all as square as possible. But in the end, we didn't have that precision. And so, having couplers that allow for that little bit of movement is ideal.
Sure.
I would say that more of a professional approach would be to have very, very precise couplers, and then you would just fix that end piece to your motor shaft directly with a solid connection. It's going to be a simpler connection. It's less to worry about coming loose, breaking. It's one less thing to have to buy, perhaps.
Yep.
But you need to make sure that your alignment is perfect, both the alignment with shaft face to face as well as the XY positioning as well. Because anything that gets off and you're going to get fatigue, you're going to eventually find that you're either going to be messing up your bearings, or if you're constantly ever so slightly flexing your shaft, you'll eventually fatigue and you could break the shaft essentially.
Right.
And it'll go all at once, probably in the middle of the race.
Yeah.
So I got these on one of these direct from China websites where I think I might have spent about $25 a piece on 3 of these.
Yep.
And this was from an RV project that I was just building personally that I had never got around to finishing. And so I can't speak on the power of these and of what they actually put out compared to what they claim to be able to put out.
Right.
But if you think about from a difficulty in integrating something like this, you don't have to worry about on a smaller boat. You don't have to worry about having. How are you going to run a shaft through the hull, or how are you going to build a gearbox to go from a vertical motor and then turn 90 degrees if you're building a more of an outboard style? So the beauty of a thruster like this is that you've got your typical brushless motor installed in this little housing. It basically helps to direct the thrust. And because it's a brushless motor, there's no brushes. It's literally running flooded underwater.
Yep.
So it's pretty simple to use. You just need to use a speed controller to run it. I would say the downside to anything that's similar to this in approach, even if it's a bigger, like you see these e-surfboards and different things that are a similar approach, if they don't have a sealed motor, then those bearings aren't going to last forever.
Right.
And so at the minimum, you would want to use it and then take it out and flush it with fresh water, and then perhaps flush it out with a bit of WD-40 or something to displace that water, and ideally not have it be rusting in there, you know. But I would say that in the long run, exposed bearings like this aren't going to last you forever.
Yeah, I think
But they're a cheap way to get it, get started.
Yeah, I think what teams have found on 2 points of what you were just making, these kind of thrusters were on the first and second place teams for the unmanned division.
Okay.
They actually were using the Blue Robotics versions of these. The T200s have been around for quite some time. They have new T500s, which are pretty powerful. They feel like a fan when they're operating. It's wild.
Yeah.
But that allows you to have them just firmly mounted right here on the bottom of your hull. And this is another thing that you can replicate and put in, think about how you design so that if one does fail for some reason, you have a backup. And then just to go back to what you're saying about flushing it out with water, a little bit of clean water and a towel really saves your design. There's already been teams that have thrown away parts of their boats because of rust, which is a good time to come back and pick up. So a lot of teams in the unmanned competition will put a drive shaft through the hole. And what they'll end up doing is trying to put bearings in some kind of grommet or some stuffing box, something in there. Personally, I think that you kind of have to get used to a little bit of water in your hull. Just once you penetrate the hull, it's just going to be part of that, and there's some ways to deal with that.
Yeah.
But what are some of the ways that a team could mitigate those kind of challenges?
Sure. I mean, so there's a thing called a bilge pump, that is designed to get water out of a boat. And even in a small scale RC model, you could still have the equivalent of a bilge pump. You can get very small, little 12 volt, 5 volt garden pumps, little things that are very small. They draw very little power, and you don't need to typically, you're not talking about a huge hole in the boat that you're constantly keeping it from sinking. You're just getting a slow drip of water that might be getting in and keeping that out. So one of the things that you can do is compartmentalize your hull.
100%.
So if you've got a breach through the hull where your shaft is coming in, and then there's nothing separating it from everything else inside the hull, once you get a little bit of water in there and the boat's rocking around, that water is going all over the place. Sure. And anything that it can splash up into, it's going to, every time you go up and over a wave, it's just going everywhere in there. But if you can have a bulkhead where your shaft comes in, and perhaps if your motor and shaft could be the only thing in that part, you've already separated it out from your electronics.
Right.
Perhaps you could have your stuffing box, and then maybe a grommet or some kind of another stuffing box or something that gives you a secondary separation from where your motor is located. And then maybe you could have it so that way you would have to flood the first compartment and the second compartment before you even get to where the motor is.
Right.
And then that way, in a situation where, worrying about the bearings and stuff like that, it's just one less thing to worry about. It's a little bit easier to take something like this, perhaps, and flush it out when it is so open to be able to, get water to it, get, WD-40 or whatever in there, versus if you've got a boat where it's all kind of down in the hull. What are you going to do? Spray WD-40 all over inside your boat? It's going to kind of get everywhere, and you're going to have to turn it over so to shake it all out and everything. So you have to kind of think about how are you going to address that.
But I think when you're talking about having two sections, it gets back to this idea too of you don't need the boat to work for a year. You need it to work for 30 to 55 minutes probably. Right. And so but you just got to wait it out.
And you can do things to help make you aware if there's a problem beyond what is able to be handled by your system. So let's say you had those two bulkheads and you had one of these tiny little, very lightweight, sort of like aquarium or little pumps that could just evacuate just a little bit of water. Then that could be in there, and you could just have it running all the time, so that way there's no the sensor accidentally didn't kick on or whatever, and it still continued to flood or whatever.
Sure.
The ones that are designed to be able to run dry, it's not going to hurt them. You would want to make sure that it is a pump that can run dry. And they don't tend to use, I've got one that runs off of 5 volt solar, and it pumps enough water that it would probably do what 99% of these boats' needs would be. Uses very, very little power. So you could just run it off of a 5 volt, battery voltage regulator off of your main power system. And if you had a second one forward in the next bulkhead, and let's say that one had a tube that came out the top of the hull, and if you saw that water stream flying up in the air, you would visually know we've reached that second compartment, and the first one's been been flooded to the degree that that first pump isn't working enough. And then you can make the call. Do we want to stop and inspect it? Are we going to continue and hope that that one can handle it? You know, you would know best what your systems can handle. But having the ability to give you feedback about any status of your boat is really, really helpful.
Yeah, and I think
telemetry data, anything about your battery life, anything about temperatures, levels of water, whatever, anything that you can know about those critical aspects about how your boat is performing. If you're not in the boat to see it, if there's some way you can see that on your display, on your dashboard, that's really, really helpful to success.
Yeah, and I think the other thing it shows too is the shape. You want to think about the geometry of what your boat is in the water. So it might be that the angle gives you an opportunity to put a pipe where you can see the water coming out. Or it might be that if you keep your electronics that need to be dry here and the ones that can be submerged here, you know, you can use this. And then the other thing is, like, if you are using some sensors, you also want to make sure you angle the camera down on your bow to make sure that you're actually not just looking up at the sky the whole time.
Exactly, yeah. And so if you've got some of the components that can be sealed in, like a plastic container, whether you could run the cabling through the side of the container, maybe caulk it or whatever. Sure. You could use a little tiny Pelican case that clips shut and is very, very waterproof. And the problem, though, is that you may not be getting any exchange of heat out of there. Right. So then you have to think about, are you running air-cooled or water-cooled ESCs or your other components that might heat up? And again, if you're going to be running water-cooled, then you have to just be aware of any time that you bring that water into that sealed container, if that pops loose and you're pumping water, you're going to fill that container with water, So double check. In the case of our trimaran, all of our plumbing for all of the water cooling, all of the plumbing connections are double hose clamped. Gotcha. With the idea that any one of them should do the trick, but if one of them was to like strip or fail, that was one of the things we decided. We're kind of investing enough in this boat that we don't want to have some stupid little hose clamp, a 50-cent hose clamp, be the thing that floods a battery compartment and wastes north of a couple $1,000s worth of cells. So. I think this
small
investment to
the coolant part actually has like a different set of materials that are very cheap but have a lot of wear and tear issues. Where if you are using a plastic tubing, you want to keep an eye on that because eventually every connection that you have, whether it's hose clamp or some kind of plastic piece, all that stuff can fail. But it's all really cheap, so just buy a couple of them.
Yeah. And one of the things you had mentioned before about was the idea of the sort of NASCAR approach in your race day ability to adapt to the problems. And so we've got a workshop space that is not like a grab it and go type space. We've got a lot of stuff that sort of lives, in its home location. So before we come to a competition like that, we essentially build a kit to take with us. We don't have like a separate kit for that. So we're like, what are the things that we would most likely need? What are the things that we would be able to fix on the spot? Even something like a soldering iron, we put in a sort of a secondary kit that we leave in the car because we could get a extension cord or an inverter and fix that kind of thing if we needed to. But any of the hand tools we might need, two-part epoxy, electrical tape, spares for things like breakers. So we didn't really talk about this much, but in the 12-volt lower voltage system items, and I feel like this is something I can make another video to kind of go into more details of this, but you're going to definitely want to have protection in those systems. The ability to have those systems disconnect if there's an issue. And so the two most common would be either a fuse-based or a breaker-based system. And the advantages maybe to the fuse systems is that they're probably cheaper, but especially if you're trying to troubleshoot something, and if you connect your power and instantly you're blowing your fuse and you're just burning through fuses trying to figure out why is this thing overloading, having a switch that's a breaker panel switch makes that process so much more, bearable, I guess. Another thing, kind of circling back to the BMS, as a boat owner myself, one of the things that I own a sailboat, and one of the things that I find is super convenient about taking this technology and bringing it into my sailboat, I have a lithium battery bank that I built with a BMS that I can connect via Bluetooth and everything. And so over the summer, I went up the mast to change out a light bulb in my masthead light. So I'm at the top of the mast, 50 feet off the water, and I was by myself. And so I'm like, I want to be able to not have the power on the whole time while I'm up there, but I want to verify that I have all good connections and everything. So it was great to be able to remotely turn on via Bluetooth, turn the battery on, check to make sure I had good voltage, which told me I had good continuity. I didn't have wire that had, dampness that was getting into it and causing too much resistance in the cabling, good solid cabling, and then kill that power, remotely turn it off again. But then the other great thing was I was able to then look at the power coming out of my BMS and see how much power is it drawing. Does this seem normal? Because when you're going through troubleshooting like this, why am I flipping a breaker? Why am I blowing a fuse? Like if you can look at the power draw and say, okay, turn on this thing, does that look normal? Turn on this thing, does that look normal? If you've got something that you're expecting 5 to 8 amps and it's blowing a 25 amp fuse, it's good to be able to see, is there some other problem, or is that's truly what it's trying to pull out of the battery, or or is it that you've got some weird pinch point where you're causing some other issue someplace else or whatever it may be. So yeah, I would say from a troubleshooting standpoint, learning how to sort of utilize sort of maybe secondary aspects of your systems. The BMS is a great way, and having one that you can remotely look at it on your phone while you're going through any of this troubleshooting and process like that. One of the things that you might have to, I've seen this happen on the race course. You've got two parallel systems that are in the same boat, and they're both vital. You've got a bigger battery bank that's pushing the boat along, but then you've got a smaller 12-volt battery bank that's doing things that make the controller work, make cooling fans and cooling motors, pumping all these things. And even if you've got the best high-voltage battery system, if your low-voltage battery dies, you're still going to be dead in the water.
Right.
So, being able to use some of the thing like a BMS to help you troubleshoot through, when I have everything in a race day scenario, like how much power is it actually drawing when everything is turned on? What is the capacity of that 12-volt battery? And then how long could I run it before I got to be critically low where things are going to start shutting off or whatever, So, and then I guess also going back to the thing you said before about, if you need a certain number of batteries, buying a few extra. One of the things that we did, we needed 48 cells for our battery pack. Now we bought it from a distributor that we've bought. I had personally bought batteries from. I've done things for other people personally where I've bought batteries, and I've never had a concern with them. But that doesn't mean that you're always going to have, this perfect scenario.
Right.
So there's always a chance you could get one of the batteries that is underperforming. And if you're talking about a 4S 12-volt battery, you've only got 4 batteries, so it's less likely than if you're talking about a 48S pack where just one of those batteries, is all it takes to cripple the system. So we ended up basically buying 52 batteries with the idea that we would go through and check them all out, load test them all, and if we did have any that underperformed, we would use those in our 12-volt bank. And then we also had them all purchased at the same time. They were all, as they always say, matched for internal resistance and voltage and everything.
Yep.
They don't, it's hard to get a distributor that truly does load tests and capacity tests. Although there are some, like SunFun Kits is one of the online vendors. They're US based. I think they're in Atlanta or someplace down south.
Okay.
That they give you the specs on every single battery that they sell when you buy like a kit from them. They've capacity tested them. They tell you how it performs under different amounts of load and everything. But you pay a premium for that.
Sure.
So you're going to be paying more for that than if you buy it where you're importing it from China. You're getting it at a cheaper rate, and then you're waiting for a couple of months.
Yeah.
Crossing your fingers the whole time that when they get there, they are going to be what you're hoping for. And I guess, again, I can make a whole separate video about my thoughts on where you're getting your batteries and what questions to be asking. I think it's always important to make sure that you're very, very clear what you're expecting to get, and that is what they're going to be sending you, because whenever there's a language disconnect or whenever there's maybe the convenience of claiming a language disconnect, there's more chance of having a disappointment with what you hope to be getting and what you end up getting, So
yeah, no, I think that's where like finding the customer service rep that you can actually talk to is pretty critical, and a lot of those companies don't have that. And teams have already run into that like as a very detrimental part of their process.
Yeah. I mean, just give an example, our wooden boat that uses 280 amp hour cells, actually, now that I think about it, we got those from a not less reputable vendor. And I guess maybe this is a good example of, at the time we wanted to buy those, our vendor didn't have any in stock, and it was going to be too long of a wait to get them in time. So we bought them from, the students actually identified who they got them from, and I don't know who it was, but maybe it's best not to maybe call out, throw someone under the bus. But they're only a couple of years old. They've never seen any real abuse other than we do fully charge and relatively fully discharge them. We still stop at that low end, but we don't do the 10 to 90%, sort of, more easy range, easier on the batteries kind of range thing. And the 280 amp hour cells, I just started testing them the other day, and they're measuring in like the 230s range. So why is it that they're performing that poorly? I don't think it's because we're wearing them out. I think it's just that they were always underperforming cells, and we just didn't have the laboratory equipment to do that kind of testing at the time.
Sure.
So
sure.
It's tougher to test bigger batteries, because when you're charging a massive battery bank, it takes a lot of time to charge it, and it takes more time to discharge it. Our current boat, the Trimaran, has a 43 kilowatt hour battery pack, and it takes a fairly long time to discharge that in our indoor storage space, where it's sitting in a trash can full of water, because we can't use more than about a kilowatt or so before we start throwing all the water out of the bucket.
Right.
It doesn't really work anymore. So yeah, I found that we really need to take down the water and run it in the water to get some load on it that's a reasonable amount. Otherwise, we're talking forever to run the battery down to check the capacity.
Well, and to run it down, but also to charge it back up, right?
So
it takes some time.
So not necessarily.
Not for you? Okay.
So